Hello everyone. Today we are going to learn about a very important topic in algebra, logarithms. If a raised to x equals n, then we can say log base a of n equals x. A must be greater than 0. A should not be equal to 1 and n must be greater than 0. For example, 10 raised to the power 2 is 100, which implies log of base 10, 100, is equal to 2. Logarithms are very useful for simplifying exponential expressions and solving equations involving dot exponents. Use of logarithms. Logarithms help us convert multiplication into addition, division into subtraction, and exponents into multiplication. This makes big calculations easier, especially in science and engineering. Types of logarithmic function. There are two common types of logarithms. Common logarithm. Base 10, written as log x. Natural logarithm. Base a, approx 2.718, written as an ln x. Both are used widely in science and math. Properties of logarithms. Let's now go over the key properties. First property. Log base a equal to 1 and log base a dot 1 equal to 0. Second property. Product rule. Log of base a dot mn is equal to log of base a dot m plus log of base a dot n. Third property. Quotient rule. Log of base a dot m by n is equal to log base a dot m minus log base a dot n. Fourth property. Power rule. Log base a dot m power n equals n dot log base a dot m. These rules simplify calculations just like algebraic identities.
Sir, can these be used in solving equations?
Yes. These are the foundation for solving logarithmic equations. Here are a few more. Root rule, log base a. Under root m, equal 1 by 2 log base a, m. Inverse rule, log base a dot 1 by m equal to minus log base a dot m. Change of base, log base a dot m equal log b dot m by log b a. Domain, range and graph. A logarithmic function fx equal log base a fx domain is equal to 0 to infinity, range minus infinity to plus infinity. Graph passing through 1, 0 point and vertical asymptote cx is equal to 0. Increase of a is greater than 1 and decrease of a is greater than 0 and less than 1. Characteristic and mantissa. In common logarithms, base 10, we break the value into two parts, characteristic, integer part. Mantissa, decimal part. Rules, for n greater than 1, characteristic is equal to number of digits minus 1. For n greater than 0, less than 1, characteristic is equal to minus. Number of zeros after decimal plus 1. Log base 10, 326. Approx 2.513 for this characteristic is equal to 2 and mantissa equal to 0.5132. Example, log base 10, 0.0047, approx minus 2.3279 for this c is equal to minus 3, m is equal to 0.6721.
Sir, what about inequalities?
If log base of fx equals log base a of gx, then we can say that fx is equal to gx, but only if both fx and gx are greater than 0. The logarithm of a negative number or 0 is undefined. So, we must make sure both fx and gx are positive to use this identity. Solving logarithmic inequalities. If the base is greater than 1, then log base of x is greater than log base of y means that x is greater than y. If the base is between 0 and 1, that is 0 less than a. Less than 1, then the inequality flips. So, log base of x is greater than log base of y means that x is less than y. Before solving any logarithmic inequality, you must check the domain. That means the value inside the logarithm must be greater than 0. Now let's look at this example. Log base 2 of x minus 1 is greater than or equal to log base 2 of x plus 1. To calculate the common log base 10 of 125 and determine its characteristics, compute log base 10, 125, characteristic and mantissa. Follow these steps. Log base 10, 125, approx 2.0969. Identify the characteristic. The characteristic is the integer part of the logarithm. Since 125 lies between 100 10 power 2 and 1000 10 power 3, the characteristic is 2. Determine the mantissa. The mantissa is the decimal part of the logarithm. From the calculation, mantissa equal log base 10, 125 minus characteristic is equal to 2.0969 minus 2 is equal to 0.0969. Final result, log base 10, 125 equal to characteristic plus 0.0969 mantissa is equal to 2.0969. Example: log 10, 125 is equal to 2. Characteristic plus 0.0969 mantissa is equal to 2.0969. For numbers less than 1, the characteristic becomes negative and a bar notation is used to denote this. For example, log base 10, 0.012, approx minus 1.9208 is equal to 2 bar plus 0.0792.
Sir, thank you. This topic is much clearer now.
Well done, everyone. Keep practicing and stay confident. Jai Hind.